In chapter 1, we have learned a statistics study. The procedure would be define your interest, right? Define your study objective. And then you need to have a good create question to collect the data. And then go collect the data. Once you have the data, we need to summarize the data. So when you after you summarize the data, then we can put it into the graph, put it into the chart. But before we do that, we need to summarize the data. So one skill we can summarize the data, we call frequency distribution, which is we need to categorize our quantitative data, put it into the right interval, so that it will help us to sketch the graph with the right information. So here we are going to learn frequency distribution. What is the distribution? A distribution of a variable that describes how the observation fall across the range of possible value. So this is definition of the distribution. Now we look at frequency distribution. Frequency distribution is a table. It's a table that shows classes or interval of data with the count of the number of entries in each class. So this is the example of the frequency distribution. It's a table. So here it has two columns. The first column gives us the information of class, or this is the same meaning as interval, right? It comes with a range from somewhere to somewhere. So during this range, how many data we collected will fall into this category. So we are going to learn how to classify classes when you create a frequency distribution table. So a frequency distribution table that shows classes or interval data, right, with a count, how many of them of the data that stay in that category. Frequency, normally we use a little f to state it. We call that the class. The class is the number of data entries in the class, which is we count. And most of the time, when we have the raw data here, and we just count the data is between 1 and 5, right? So we use a tally to count it. So you count those that 1, 2, 3, 4, 5. So here it has 5, and that's why the frequency number is 5. So this is an example. It's a frequency distribution table. Now, how do we find the class limit? On the first column, it's a class, right? So class is an interval. It tells us from where to where. So the first class, this is the first class. The class limit is between 1 and 5. And there are 5 data located fall into this category. The second class limit is between 6 and 10, and there are 8 data fall into this category. And we just continue to construct the class level. Depends on how many classes the question asks you to find it. So we are going to learn how to produce the class limit. Here, this is what we call class limit. So it's from somewhere to somewhere. Now with the class limit, this is a limit. The blue number here we call lower limit. red color here we call upper limit. So this is a lower, this is upper. Keep in mind, when you construct class limit, the upper limit on the first class never overlap with the lower limit on the second class. Or we can say the upper limit on the third class never overlap with the lower limit on the fourth class, which is the upper limit never overlap with the next entry lower limit or with next class lower limit. Right? These two, they never overlap. So which is 15, and then we move on to next number 16. Up to 20, then 21 up to 25, then go to 26 up to 30. So when you produce the class limit, remember your upper limit never overlap with the lower limit on the next class. Now class width. When the question provides a table, finding the class limit just by looking at the table, we subtract two lower limit, which is we call consecutive. Consecutive. I might spell wrong, alright, but consecutive. Let me see. There's a word there. Alright, consecutive. Yes, I think I'm SE. Let me rewrite it. Consecutive. Okay. Which is the number, the lower number right next to each other. Or you can subtract 6 and 11 because they are the two numbers right next to each other, right? We call the number right next to each other, they are consecutive. When you subtract two consecutive numbers on the lower limit, which is when I use a 6 subtract from 1, is equal 5. So 5 is the class width. Class width. When you subtract 11 from 6, you will get the same. You will get the same number is 5. When you subtract 16 from 11, you get the 5. If you continue to subtract two consecutive numbers on the lower limit, guarantee you'll get a 5 because the class width must be equal on each class level when you have the frequency distribution table. Same way, you can subtract the two upper limit. We can subtract two upper limit right next to each other, which is two consecutive value on the upper limit. So if you subtract 10 from 5, you get a 5. When you subtract 15 from 10, you get a 5. If you continue to subtract the two consecutive number on the upper limit, guarantee you get a 5. Because the class width must be equal on each class level. Now, do not mess up. Do not subtract the two horizontal number, which is never subtract these two. Turn to the class width. Your class width always vertically subtract. You can subtract two lower limit or two upper limit, but they must be vertical direction. Do not subtract the horizontal two number because they are the meaning of the range. When you subtract these two, that's the range of the class. So you will missing one value or sometimes 1.5 value if you just subtract horizontally. So remind yourself, always subtract vertically to find the class width. Okay, So now, construct the frequency distribution table from the data. Step 1, you need to define the range of the data because you need to find the class width, right? So we start over. Let me start over. Create the construction. When you want to create a frequency distribution table, step 1, we need to find the number of classes. Then step 2, you need to find the class width. Step 3, you need to find the class limit and make the tally mark to each data entry in the row of the appropriate class, which is you count how many data that fall into the correct category. And then you count the tally mark to find the total frequency for each class. Now, I'm going to show you how to create a frequency distribution table from here. So the example here, we have the data set here. It has a total 30 US adult in a recent year that spent on the prescription. The amount is spent on the prescription. So now we need to summarize the data, put it into the frequency distribution table. So how do we do that? Step 1, we need to determine how many classes they want to put the data into the category. And you always will receive the information from the question. Normally, normally with the frequency distribution table, you will see the classes between 5 and 20. If your classes is less than 5 or larger than 20, you won't be able to see the shape of the data, or you won't be able to see the shape of the distribution. So between 5 and 20 classes, that would be the best presentation. From this question, they ask us to categorize those data into the 7 classes. So in order to put it into the 7 category, we need to find a range first. So finding the range is getting from the maximum, which is the largest size or largest number of your data, to subtract the smallest data you have. Right? So this is the largest data, and this is the smallest data from your raw data. Now here, I can see the largest data we have here is 405. So this is the largest data. The smallest data from the raw data here is 155. So I subtract 155. When I subtract these two, I get 0, 5, I get 250. Now, find the classes. It's 7, right? They want the 7 classes. So we use the range to divide by number of classes. Then we can solve for the class width. So we substitute the 250 into it, divide by 7. Alright, so when we divide it, the number here, let me pull out my calculator. When I use a 250 to divide by 7, I get 730.714. I get a 35.7142. It's keep going. Now, because our raw data, they are all integer, which is they are all whole number. So because the characteristic of the data, they are all a whole number, So normally we will round up the decimal into the whole number. So here, it doesn't matter whether on the 10th place number is 7 or is 1, it doesn't matter. We always round up to the integer, to the whole number. So we take the 36 as a class width. In another word, when you divide it, if you get 35.001, you round up the decimal into the integer. Another condition is even when you can divide it evenly. For example, when you divide it and you get exactly 35, but we can treat the 35 as a 35.00, right? So same way, we'll still round up the decimal into the whole number, which is, this is 36 as well. This is a little bit odd, but we have to do this way. Otherwise, you are going to miss in one category. When we go back to class, we will do the in-class activity, and there's an example. You will see the example like this. All right, so we will work on this one in the class. But now here, you just need to know, when you find the class width, whatever number here produced, you always add a 1 to the front. Always. Even they can divide evenly, you still push 1 to the front. Okay, so when you have, for example, the range is 100, when you divide by 5 classes, you get a 20, right? 20, although they are divided evenly, but we still push 1, we still bring 1 to the integer part. So it turns to the 21 as your class width. Now, once we have the class width, this is the class width, right? Let me change the color. This is the class width. Class width is equal to 36. Now we are going to construct the lower limit on the class width column. So lower limit, we start from 155 because this is the minimum on our data. So you write down 155, and then the next number is getting from, when you have the 155 add the 36, you'll get a 191. 191, you add a 36, you'll get 227. So you continue to add 36 with the lower limit. Then you'll get the next level lower limit. So this number, when you add the 36, it turns to 263. Continue to add 36, you'll get 299. And when you continue to add 36, you'll get 335. Add 36, you'll get a 371. And here, you stop here. Why? Because this is the 7th class. So you will stop here. Okay. Now, finding the upper limit. Remember, I just mentioned upper limit never overlap with the lower limit on the next class. So the lower limit on the next class is 190, which is upper limit here must be 190. Right? So the lower limit on the next class, it begins with 191, which is the upper limit on the previous class. Upper limit on the previous class must be 1 less than lower limit. Same way here. Finding the upper limit on the second class, this number must be 1 less than the lower limit in the next class, which is the lower limit is 227, right? Alright, I will continue in the next lecture.